Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Syarika binti Azmi. I will present my video of MTN. The topic is one Neumann model. My subtopic is input. What is meaning by input? Input is any information of the data that is sent to computer or processing is considered input. Input or user input is most often sent to the computer using an input device. The picture in an example of input being sent from the computer keyboard to the computer. Okay, for the input device are peripheral used to provide data and control sign to a computer. Input device allow us to enter the raw data for the processing. Okay, for the example of the input device, one is keyboard, mouse, microphone, webcam, touchpad, graphic tablet, and scanner. Computer software can receive data in the form of an input stream, which a flowing sequence of the data that can be directed to specific function. The directed channel in which the data stream flows is known as a pipeline, and changing its direction is known as a piping. In Unix like operation systems such as Linux or BSD, the input stream is one of the three standard data streams. It's known as the data standard input stream and often abbreviated as STDIN. In general, input can also refer to a contribute or feedback information or word. For example, someone may ask you for your input about a project that they are undertaken at work or school. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mira Nabila binti Marapi. I'm from Group 3, which is present our title is one Neumann model. In one Neumann model, my subtopic is output. As you can see at the screen, my subtopic is output. Okay, meaning of output. Output is any information that has been processed by and sent out from a computer or similar device is considered output. A simple example of output is anything you view on your computer monitor. The bottom half of the image to the right shows data being sent from a computer to a printer, which is considered output. The data is then printed onto a piece of paper, also considered a form of output. Okay, next one is example of output. First is digitized speech. Digitized speech is anything spoken that has been converted from an analog, a binary signal, to be used for playback at a later time. Second is hard copy. Hard copy is anything that has been printed on paper. Hard copies allow data to be read without the need of a computer and are often required when someone needs to sign a document. The third one is soft copy. Soft copy is a copy of text stored on the computer and only accessible through the computer. The most common method of displaying a soft copy is through a computer monitor or other display. Okay, that's all from me. Thank you.
Assalamualaikum dan hello everyone. My name is From Xiaoxia. Today I'm going to present my presentation. The topic is one Neumann model. The subtopic is main memory. Main memory, primary memory, or system memory, random access memory, is a hardware device that allows information to be stored and retrieved on a computer. RAM is usually associated with RAM, which is a type of memory module, because information is accessed randomly instead of sequentially like it is on a CD hard drive. The computer can access the data much faster. However, unlike ROM or the hard drive, RAM is volatile memory and requires power to keep the data accessible. If the computer is turned off, all data contained in RAM is lost. Type of RAM. Over the evolutions of the computer, there have been different variations of RAM. Some of the more common examples are DIMM, RIM, SIM, SODIMM, and last one is SORIMM. Additional RAM information. As the computer boots, part of the operating system and drives are loaded into memory, which allows the computer to access the instruction faster and speed up the boot process. After the operating system has loaded, each program you open, such as the browsers you are using to view the page, is loaded into memory while it is running. And if too many programs are open, the computer will swap the data in the memory between the RAM and the hard disk drive. The history of RAM. As we can see, the first form of RAM came about in 1947 with the use of the Williams tube. It utilized a cathode ray tube CRT, and data was stored on the face of the CRT as electrical charges port. The second widely used form of RAM was magnetic core memory, invented in 1947. Frederick Witt is creator, with much of the work having filed for several patents related to the design. Magnetic core memory worked through the use of tiny metal rings and wire connecting to each ring. One bit of data could be stored per ring and accessed at any time. However, RAM as we know it today as solid-state memory was first invented in 1968 by Robert Daniel, known specifically as dynamic random access memory, or DRAM. Transistors were used to store bits of data. This is the reference. Okay, that's all from me. Thank you.
Assalamualaikum and hello to everybody. My name is Muhammad Syafiq bin Ramli. I'm from Information Technology. My lecturer name is Dr. Ismail. I would like to present about the subject MTN, about the bomb minimum model. My subtopic is CPU, that is a central processing unit. First of all, I would like to say about the Neumann Architecture. In the 1940s, a mathematician called John von Neumann described the basic arrangement of a computer. Most computers today follow the concept that he described, although there are other types of the architecture. His computer architecture design consists of a control unit, arithmetic and logic unit, memory unit, register, and input-output. For Neumann architecture is based on the store program computer concept where instruction data and program data are stored in the same memory. This design is used in most computer produced today. So, central processing unit. The central processing unit is an electronic circuit responsible for executing the instruction of a computer program. It is sometimes referred to as the microprocessor or processor. The CPU contains the ALU, CU, a variety of register, and the clock. So the register is a high-speed storage area in the CPU. All data must be stored in the register before it can be processed. The example of the register is MAR, MDR, SC, PC, and SAR. MAR is a memory address register that is whole memory location of data that needs to be accessed. MDR is a memory data register, whole data that is being transferred or from memory. SC is accumulator, where intermediate arithmetic and logic results are stored. PC is a program center containing the address of the next instruction to be executed. SSR is a current instruction register, contain the current instruction during processing. The arithmetic and logic unit, ALU. The ALU allows arithmetic and logic operation to be carried out. The control unit. The control unit controls the operation of the computer, ALU, memory, and input-output device, telling them how to respond to the program instruction it has just interpreted from the memory unit. The control unit also provides the timing and the control signal required by the other computer components. The clock. Instructions are carried out to the bit of the clock. Some instructions take 1 bit and other more than 1 bit. Very roughly speaking, the faster the clock, the more clock bits you have per second. So the more instruction per section you can do, and the faster your computer will go. Buses. Buses are the means by which data is transmitted from one part of a computer to another, connecting all major internal components to the CPU and memory. A standard CPU system bus is comprised of a control bus, data bus, and address bus. The address bus is carry the address of data between the processor and memory. Data bus carry the data between the processor, the memory unit, and the input-output device. Control bus is a carry control signal or command from the CPU in order to control and coordinate all the activity within the computer. So that's all about my topic. Thank you.
Assalamualaikum and good afternoon. My name is Muhammad Azifar Khair Muhammad Azam, and I will be presenting the topic ALU and the accumulator. Okay, so what is an ALU? Well, an ALU or arithmetic logic unit is a fundamental building block of many types of computing circuits, including the central processing unit, which we all know as CPU, and FPU, also known as floating point unit, and graphics processing unit, GPUs. A single CPU, FPU or GPU does not necessarily contain only one ALU, but in fact it may contain multiple ALUs. So, from this statement alone, we know that the arithmetic logic unit, ALU, is a very important component in the computer. Moving on to the history of the ALU. Mathematician John von Neumann has proposed the concept for the ALU in 1945 in his report on the foundation for a new computer called the INVEC. Many early computers such as the PDP-8 had a simple ALU that operated on one data bit at a time, and in 1948, computers started to have multiple discrete single-bit ALU circuits. Then, in 1967, Fairchild introduced the first ALU implemented as an integrated circuit, the Fairchild 3800 with 8-bit ALU with the accumulator, which is the register for the ALU itself. And then, microprocessors began to appear in the early 1970s, and over time, transistor geometries has become smaller following Moore's law, and therefore wider ALUs became more feasible to be built on microprocessors. Okay, so a volume model CPU contains the arithmetic logic unit, ALU. This ALU is actually capable of performing arithmetic and logical operations such as add, subtract, and or and NOT operations. And the ALU is also lets data enter and leave the CPU, which means that the ALU is the one component that is controlling the data flow in the CPU. The size of input quantities of an ALU is referred as word length or word size. The size of quantities processed by the ALU is the word length of the computer and does not affect what the computer can compute. A computer with a smaller word length can do the same computation as a computer with a larger word length, but it will take more time. Today, we often found the word length or word size referred by a CPU, whether the CPU is a 32-bit CPU or 64-bit CPU. Okay, so as we see here, the latest Intel CPUs uses 64-bit micro architecture, and from the animation here, we can see that a 32-bit processor can compute the same amount of 64-bit processor, but with less speed due to its lesser memory capacity. Okay, next we move on to the inputs of an ALU. Data is called operands, and a code to indicate the operation to be performed. And the output of the ALU is the result of the performed operation. Basically, the ALU is the part of the CPU where the actual processing takes place. Next, we move on to the accumulator, which is a register in the ALU. So, first thing first, what is a processor register? Well, a processor register is one of a small temporary data storage that is a part of the processor. A register holds an instruction, a storage address, or any kind of data, such as bit sequence or individual characters. In a 64-bit computer, the register must be 64 bits in length. However, there are smaller registers that some computers use, which are called half registers, which are used to process shorter instructions. So, the register in the ALU is called the accumulator. The accumulator stores any values that are needed for the arithmetic operation and is the only general purpose register in the CPU. I think that is all for the topic ALU and the accumulator. I am Azim Farhan. Thank you.